Okay, so we are going to continue what we did last time. We were talking about lines, right? Y'all remember that? We had talked about the rectangular coordinate system, I had called R2. We had talked about if you want to graph a line, someone gives you a linear equation in two variables, then the way you could do it was by finding the x and y intercepts, and then graphing those 2 points, and then drawing a straight line through them. So that's what we ended with last time. We were in section 3.2. We did not finish the section, so there's two things that we do need to talk about. First of all, horizontal lines. You know what? Hold on a second. There we go. Horizontal lines and vertical lines. I forgot to tell you, I have some good news and bad news. So the bad news is that I have to end class a little early today because I'm going to be subbing another class. I just found out I'm going to sub another class, and I'm not prepared for that class. I need to figure out what I've got to do, and that class is at 11 o'clock. So just to let you know, I'm probably going to cut us out of here about, 10 minutes early, maybe 15, just depends. The good news is that I'm going to end class early, and so bad news and good news, Well, good news to you, bad news because it gives us less time to cover what we need to cover. But, we'll be all right, I think. So, all right, so horizontal and vertical lines. The two types of lines that we did not discuss last time were the cases where we have, I'm going to draw them side by side. We have a horizontal line, and I'm like jittery today or something. Get warmed up here. Horizontal line is like the horizon, right? It's flat, left to right, it's flat. Vertical line goes up and down. And when we have a vertical line or a horizontal line, our equation that we had looked at before changes. All right, so if you recall from last class, the general equation we had, do y'all remember what our general equation looked like? Let me see if I can bring this up so you remember this. Day 6. Linear equation, two variable. Remember this? This was a linear equation, two variable. We had basically a number in front of x, we had a number in front of y, and then we had equal sign, then a number, right? That was the linear equation in two variables. Well, today, what I'm here to tell you is that when you have a vertical or a horizontal line, the equation changes and it looks weird, okay? So let's just take a look at this first one. The horizontal line, which is on the left, the equation becomes y equals b. Now, what that means is that you still have an equation, right? It's an equal sign. You have y in the equation, but b here is just a number, all right? So I'm going to point that out here. I'm just going to draw a little arrow from the b. This is just a number. Notice what does not appear in that equation. What's not in that equation? X, right? X is not there. So if you have y is equal to a number, that means that you have a horizontal line, right? And that horizontal line passes through, see the y-axis here? It passes through at a height up and down of b. So whatever that number is, that's where your line crosses through the y-axis. I'll give you a specific example in a second. This is just general. Now, for a vertical line, what do you think it is? X equals a number, right? Now, we won't use b. We'll use a different letter. So I'm just going to say x equals c, all right? We reserve b for the y-intercept, like where you hit the y-axis. So the equation here would look like x equals c. Again, c is just a number. And c, of course, is where you would actually hit the x-axis here. Do you agree that any horizontal line I draw has to hit the y-axis? If I draw a line left to right, flat, it has to hit the y-axis. If I draw a vertical line up and down, I have to hit the x-axis. But notice something on the horizontal line. Does it have an x-intercept? Does the horizontal line have an x-intercept? Does the horizontal line ever hit the x-axis? When I say x-axis, I'm talking about this axis here. Does it ever hit that? No. So horizontal lines don't have x-intercepts. So you can't go try and draw a horizontal line the way we did in class last time, because you can never find the x-intercept, because there is none. And then with the vertical line, you don't have y-intercepts, do you? So you can't find a vertical line that way. So that's why when you look at an equation of a vertical or horizontal line, you have to just see it and go, oh, wait, hold on, I'm missing one of the variables, therefore it's either horizontal or vertical. Okay? So here's some examples. Example, I want us to sketch x equals -2. Now, when you look at that, you say, wait a minute, this is not a linear equation in two variables, right? Because I'm missing a variable. I'm missing y. But because I'm asking you to sketch it, I'm telling you that it's a line, and I want you to actually sketch that line in two-dimensional space. So let's go ahead and try that now. Is this going to be vertical or horizontal? Vertical. Now, how are you going to remember which is which? The way that I remember it is what this is saying is x is -2, right? So let's go to -2 on the x-axis. That's here. I must have a point there. But x being -2 means that every point on my line has to have an x of -2. So if I draw a point up here, do you agree that the x-coordinate is -2? Any point up and down would have an x-coordinate of -2. Therefore, it must be a line that goes through like this. The next one next to this, y equals 0. Try and trick you here. Y equals, yes. Yes, I will. Let me see where I'll start. I'll start it over here. Y equals 0 means that your y coordinate must be 0, right? Your y is up and down. So I'm going to draw a dot up and down 0 so I don't go anywhere, right? So I'm at the, what do you call that point right there? The origin, right? I'm at the origin. The question is it up or down, left or right? So think about it. If I drew a point up here on the y-axis, does that have a y coordinate of 0? Y coordinate of 0. This is like maybe, what, 0, 1, something like that. Remember, the first coordinate is left and right, the y coordinate, and the second coordinate is up and down. So does that point right there have a y coordinate of 0? No, it has an x coordinate of 0, but not a y. Do you see what I'm saying? So that is not going to work, will it? What about a point like this? Does that point right there have a y coordinate of 0? Yes? How about this point over here to the left? That have a y coordinate of 0? Yes. Every point, actually, that's right through, what do we call that line through this way? Left and right, what line is that? That's the x-axis. It actually turns out that y equals 0 is a line, horizontal line, that just crosses right through the x-axis. Now, had that been y equals, let's say, 1, then it would have been a horizontal line, just move it up 1, right? The whole thing would be up 1 instead. Is that okay? Y'all have any questions on that? Okay, let's move on then to 3.3. We're going to talk about something called the slope of a line, also known as its rate of change. And I'm going to try and motivate this idea with an example, all right, something that we might be able to connect to like a real world situation. Let's say Susan makes $18 per hour at her job. Then this is true. All right, here we go. I'm going to draw a little table on the left side. We call that a T table, because when you draw it, it looks like a T. Really long, weird T, but it looks like a T. So what I'm going to have is I'm going to call X, I'm going to let X be the hours that she works. Sorry, that's kind of crammed in there, hours. And I'm going to let Y be equal to the money she makes. Okay, just a little dollar sign there. So if Susan works 0 hours, how much money will she make? 0, right? You're just doing 18 times, well, she's not working, so nothing, right? 18 times 0. She works 1 hour, she makes 18, right? She works 2 hours, she makes 36. She works 3 hours, she makes 54. You'll agree? So what are we doing to figure that out? How are we determining what Y is? How are we determining what Y is here? We're multiplying it. We're multiplying what by 18? X, right? We're saying the number of hours just times however many, sorry, the number of hours she works times 18, correct? So could I write this then? Y is always equal to 18X. The money she makes, this is the money, is equal to 18, that's how many dollars, times the hours she works. Do y'all agree with that? Yes? Okay. But Y equals 18X, isn't that a linear equation in 2 variables? Right? So it's a line. Isn't that a line? Is it horizontal or vertical? I mean, I'm saying, is it horizontal or vertical or neither? Neither, right? Horizontal line would have to have, right? Horizontal line would have to have no x's in it. Vertical line would have to have no y's in it. This has both x's and y's. When we have x's and y's in a linear equation, 2 variables, then it is going to be just a line, right? Not horizontal, not vertical. Y'all follow that or not? Okay. So what I'm trying to get you to see here is that if we went and now said, okay, let's try and graph this, you could start plotting some points like we did for homework. I could plot the point. The first point would be 0, 0. I'm circling it over there, right? Isn't 0, 0 that ordered pair 0, 0? 0 for x, 0 for y. That's our origin. The next ordered pair would be what? 1, 18. So I need to go out to the right 1 and then up 18. So let me change my scale. Remember how we talked about scale last time? I'm going to go 1, 2, 3 to the right. But up and down, I'm going to count by 20s. 20, 40, 60, something like that. Then if I go to the right 1, I should go up 18, shouldn't I? That's my next point. If I go to the right 2, I should go up 36. And if I go to the right 3, I should go up 54. And you notice that all those lie on a line, right? Now, what if she made $7 an hour? How do you think that line would look? Would it look like that? how would it change? How do you think it would change? Would it become steeper or would it become more flattened out down? It'd become flattened, right? If she makes $100 an hour, right, then that thing would be way up there, right? Steep, very steep. Do y'all see what I'm saying as far as steepness is concerned? So somehow that number right in front of the X somehow controls how steep your line is. And that number in front of the X is what we call the slope of the line. The bigger the number in front of X, the steeper the line. The smaller it is, the less steep, the flatter. Okay, so that number controls what we call the slope. My wife was working in the ER up here near Santa Rosa up here, and she was telling me that some of the doctors there make about $300 an hour. Yeah, $300 an hour. Well, if you change your scale, you can actually flatten it out. You know, that is important in this. If I tried to draw someone who makes $5 an hour here on the same, using the same graph, right? If they make $5 an hour, then how much do they make for 1 hour? 5, so that would be down here. And then 10 for 2. See what I'm saying? It would look like this. That's what a $5 hour per person would look like. What would $100 an hour look like? Well, they wouldn't even be on this chart, would they? I would go out 1 and go up 100, which would be way up there. And I would draw my line like this. Do you see that? So, anyways, just trying to get you to see the relationship between the number in front of X and how it controls our line. That is known as the slope. So that's what we're going after here now, all right? The slope of a line measures its steepness. I don't even know if that's a word. I'm kind of making this up as I go here. Steepness a word? It's good enough, right? You understand what I mean? All right, we're just trying to communicate. So the slope of a line measures its steepness. Now, given 2 points, bless you, on a line, we can always find the slope. That's very important, okay? If you're given 2 points on a line, you will always be able to find the slope, okay? Always. And a lot of your homework is going to be just this. I give you 2 points, find the slope. Now, I'm going to go back to that picture we just had, and I'd like to kind of focus on something here. I'm going to zoom. Oh, whoa, 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 whoa. Don't do that. Kind of focus on something here. I'm going to get rid of those other lines I put in here. Okay. Now, look at that line there. Do you agree that if I pick one of these points, let's say I pick this one right here, the second point we drew, and try and get to that third point we drew, the way I get there, I could go across that diagonal line, right? But I could also go up a certain amount and then straight over, and that would get me there, right? The words we'll be using is I will rise a certain amount, right? And then I will, well, what word do we use to say go that way? We use run. I don't know why, that's just the word we use. Rise is up and down, run is left and right. So I would rise by a certain amount and I would run by another amount. So what about getting from that point to the next one? Would it be the same rise and the same run? Looks like it, right? And if you started back at the origin, from the first point to the second point, that rise and that run should be the same. And on lines, that's the whole idea, is that when you go from one point to the other, the rise and the run should be the same. Rise, run, rise, run. So we need a way of somehow determining that rise and run from someone giving us 2 points. So here's how we'll do it. This is all part of one note right here, this piece right here. Given 2 points, we can find the slope. Here's how. Okay, first of all, someone has to give you 2 points, don't they? So let me say let first point be, I'm going to call it, watch, x1, y1. Now what I've done, instead of writing x and y, I wrote x with a little, what do we call it when we put a number on the bottom like that, or something on the bottom? You know what we call that? Subscript. You ever heard that before? Subscripting? Okay, all you're doing is putting something below the letter to the bottom right corner. I am subscripting the x and the y to let you know that, look, this is an x and a y, but it's the x and y of my first point. So I put a little 1 there. So the first point's that one. Let second point be, what should I call that one? X, y, how should I subscript those? 2, 2, okay? Does that make sense? You have an x coordinate of the first point, a y coordinate of the first point, an x coordinate of the second point, a y coordinate of the second point. Then the slope is equal to, we use a letter for the slope. We use the letter capital M, or sorry, M, not capital M. We use M to always represent slope when we're talking about lines, okay? M, the letter M, is equal to the rise divided by the run, which will be equal to, it's just a calculation you have to do, all right? You just have to do this calculation. It is the y2 minus the y1 divided by the x2 minus the x1. That is the computation for finding slope. And remember, I let you use little cheat sheets on your exam, right? That is definitely a formula that I would encourage you to have if you don't remember it, all right? The rise over run. Questions? Think about it. y2 minus y1, right? y2 minus y1 is the difference in the y coordinates. Up and down is y coordinates. So y2 minus y1 tells you how much the y's differ, so how much change you have to go up and down. The x2 minus x1 tells you how much change you have to do left and right. Now, I want to point out a couple of things. If your rise is positive, I'm going to put a little plus with the circle around it to mean positive. If the rise is positive, you move up. If rise is a negative number, you move down. And most people are comfortable with that. Positive rise go up, negative rise go down. Does that make sense? But on the run, you got to make sure you go the right way. If run is positive, you move right. If run is negative, you move left. Okay, and that's all part of this one note right here. Just keep that in mind. When you calculate the rise on top, if it turns out to be a negative number, that actually means you're not going to rise, you're going to go down. But let's just practice real quick finding some slopes. You all ready? Find slope of line through these points. And I'm going to give us a few examples here. So I don't want to have to rewrite those instructions over and over. So I'm going to do example A, example B, example C, okay? That way I don't have to keep on saying, find the slope of the line through these points, find the slope of the line through these points. Okay, so the first one, let me give you these points. How about -4, 2, and 7, negative 3. All right, you ready to find the slope here? I gave you 2 points, right? So you can find the slope. So the way we're going to do it is, first thing, we have to figure out which of these points do we want to say is our first point, which one is our second. And it turns out, I'll show you, that it doesn't matter which one you call the first and the second. It'll work both ways. So I'm going, because I think it would be most natural here, to call this first one our x1, y1, and our second one x2, y2. Do you agree with that? I'm just going to put it underneath each of the coordinates. That's my choice for picking my points here. What are things you can't do? Don't call this x1, x2, y1, y2. That's wrong, right? It's your xy for your first point, your xy for your second point. So you can't, if you mix those up, then the formula is irrelevant. It's going to be wrong. Okay, so let's compute the slope now. The slope will be equal to my y2 minus my y1 over my x2 minus my x1. Now, I kind of threw some things in here to try and confuse you. What's y2? Negative 3. And I'm going to subtract from that y1. What's y1? 2. Right, so I'm taking negative 3 and I'm subtracting 2. Now do the bottom one. That's 7, right? That's x2. Subtract what, though? Subtract x1, but x1 is negative 4. So you're subtracting a negative, aren't you? And whenever you see minus minus, it always turns into plus. So I'm going to leave the top just for now. Just keep in mind the bottom is actually turned into 7 plus 4. That's just a property of sign numbers. Now on the top, what's negative 3 minus 2? Negative 5. What's 7 plus 4? 11. This is my slope. Now, I also did look at that real quick and make sure I couldn't reduce the fraction. Like I couldn't take that and make it, you know what I mean by reduce? Like had it been like 4/8, I could have made it 1/2. If you can do that, you try to. All right. So that's it. That's my slope. So let's just see here. I mean, we're done. We're done. We've answered the question. But let's just look at something real quick. If I were to have graphed these 2 points, right? The first point, negative 4, 2, would mean I would go which way to try and plot that first point? How do I graph it? Negative 4, 2. Have a point starting at the origin there. Where do I go to plot negative 4, 2? Left 4, up 2. So if I did that 1, 2, 3, 4, up 2, I would have a point here. And then if I plotted the other point, I'd have to go which way? Right 7, down 3. So I'd be like 1, 2, 3, 4, 5, 6, 7, down 3, 1, 2, 3, somewhere around there. And then I connect the 2 with a straight line, right? What do you notice about this line compared to the person who made $18 an hour? $18 an hour look like this, right? Yeah, this one, it's like this, right? So if you read it like a book from left to right, the person making $18 an hour, we would say that was like increasing, like a roller coaster going up, right? This one is going down. And the reason it's going down is because our slope turns out to be a negative number. Isn't negative 5 over 11 a negative number? Negative divided by positive is negative. So let's just look. If I wanted to get from this first point that I highlight in yellow, if I want to get from the yellow point to the green one, then how would I get there? I would have to go down a certain amount, right? Down. And then I'd have to go to the right. So my rise should actually be a negative number, shouldn't it? My rise should be negative, so down. And my run, 11, should be positive, so to the right. Y'all see that? So all I'm doing is showing you that the slope we found matches with what points we have. Now, someone might ask me this question. Maybe not. Say, look, what if I started at the second point, the green one, and I asked you how to go back to the other one? I would go up, right? And then I'd go over this way. And then someone would argue with me, wait a minute, now your rise is what? Positive, and your run is negative, right? So someone's like, well, wait a minute, how can it be the red one down and to the right 11 when if you go the other direction, it's up and to the left 11? Well, the answer would be this. Take this slope over here, negative 5 over 11. Do you agree that that's the same as 5 over negative 11? Do you remember what we said about negative signs on fractions? The negative can be on the top or on the bottom. And notice if I change it to 5 over negative 11, doesn't that tell me rise up 5 and then go which way? To the left 11. So it's the same thing. You get the same effect. So let me really see if you understand this. What if I told you to start at this point I'm circling here in red, and I said, give me another point on this line, but not that green one down there? How could you do it? I mean, how could I physically get to another point? If I go down 5 and over 11, won't I be at the green one? Which is saying, I'm saying I don't want that. So how could you get another one? Instead of going down 5 and to the right 11, I could do what? Go up 5 and to the left 11. So if I go up 5 and to the left 11, holy shit, look where I'll be. Won't I be around here somewhere? And isn't that just another point somewhere on that line? So the slope allows you, once you have the slope of a line, it allows you to just hop around and get a bunch of points on your line. That's what it will allow you to do. So the slope is very important to us. Let's try another one. This one I'll say is part B, so same instructions. Let's try and get from, 1/2, -2, and 3/5, -5. Oh, man. Yes, those are fractions. Happy Monday. X1, Y1, X2, Y2. I first label my points. And then I come in here and I say, I want to find the slope, so I'll call it M. By the definition of M, it's Y2 minus Y1 over X2 minus X1, which is okay, what's Y2? -5. I'm going to subtract now whatever Y1 is. What's Y1? -2. So I'm subtracting a negative, so it will become a positive, won't it? And then on the bottom, I gave you the pleasure of doing some fraction work here. X2 is 3/5, and I'm subtracting from that 1/2, which is, okay, let's take care of the top. That's really -5 what? Plus 2. On the bottom, hey, I'll get to that in a second. What's -5 plus 2? -3. Over. Now, let's take care of that denominator. I need to add two fractions together here, don't I? I need to put those together? Let's see how good you are at this. 3/5 plus 1/2. How do you add fractions? What do you have to add two fractions together? Common denominator. So what common denominator can you use for those two fractions? 10. So what you have to do is you got to turn that 5 into a 10 on the first fraction. You got to turn that 2 into a 10 on the other fraction. So how do I turn a 5 into a 10 using multiplication? What can I multiply 5 by to get 10? 2. So what I'm going to do is next to the 3/5, I'm going to multiply by 2 on top and 2 on bottom. Have you all seen it done that way before? Something like that? Yes? I don't know, actually. Thank you for pointing that out. Do y'all see why I put a plus there? Do y'all see that plus? Thank you for pointing that out. Should be a minus, shouldn't it? Is that why you were like looking over there? Just point it out, okay? I am human. I'm not a machine. I make mistakes. I remember that Rocky. No, that's old school. Rocky 4, when he fought Ivan Drago. He's not a machine. He bleeds. You can beat him. Okay. Negative sign. Sorry, I changed it up there in the top right also. That's a minus sign between those. So I multiply top and bottom by 2 on the first fraction. What about the other fraction? What am I going to multiply by? 5 on top, 5 on bottom? Okay, so let's do those multiplications. Straight across, the first two fractions, 2 times 3 is 6. 2 times 5 is 10. Then minus the other one straight across, 1 times 5 is 5. 2 times 5 is 10. Now that they have the same denominator, all you do is subtract the numerator. 6 minus 5 gives you 1, and then on the bottom you keep the denominator. So 3/5 minus 1/2 is 1/10. So that is my denominator over here, 1/10. Now I'm not very happy with this because I have what's called a complex fraction here. It's actually a fraction, but part of my fraction is a fraction. You know what I mean? So what I'd like for you to do is remember that division is the same as multiplication of the reciprocal. In other words, this. Take this over here, and I want you to look at it this way. Isn't this the same as -3 divided by 1/10? Isn't that the same thing using that old school division symbol? But back when you were learning division, you were told that division is the same as multiplication of the reciprocal, which means you flip the 1 over 10 over, and you get a 10 over 1. But you change it from division to multiplication. So what's -3 times 10 over 1? Well, that's the same as -3 over 1 times 10 over 1, which is, multiply straight across, -30 over 1, which is -30. Do you agree? -30? So what is the slope of this line? The slope of the line is -30, okay? What's your rise and what's your run? See, this is the tricky part. If your answer comes out to be a number like this, you might be a little confused as to what your rise and run is. But just go back. -30 is the same as -30 over 1, isn't it? So what's your rise here? If I'm trying to get from one point to another, what's my up and down, or which one is it, up or down? Down how much? 30. You'd have to go down 30, and then what's my run? 1. I just go to the right 1. So this is a very steep line that's pointed down, decreasing. Right? So if I were to graph this, it would look very much like something like that. Make sense? So just keep in mind right there that if your slope is an integer, a nice number, it can always be written as that number over 1, and then you have your rise and your run right there. All right, let's go on to another concept here. Those are the only examples I'll do for those. Your next one, I want to talk about two important lines called parallel and perpendicular. Two special types of lines, parallel and perpendicular. What are parallel lines? Have y'all heard parallel lines before, right? What is, if you were trying to explain to somebody what two parallel lines were, what would you say? What's that? They're like side by side? Can they be just anything side by side? There's something special about it, though. They never touch, right? Y'all kind of heard that before? Parallel. These are non-intersecting distinct lines. Non-intersecting means they never hit each other, right? They never cross each other. Distinct means they are two different lines. Because what if I did this? I mean, I want you to understand where the distinct comes from. What if I drew this line right here, and I said, look at this red line. Are they parallel? Well, they look parallel, right? They look like they're not going to hit. I know my drawing kind of sucks, but the idea there is that they wouldn't hit, right? But what if I said, I draw that blue line, then I come in and right on top of it, I draw a red line. Would you say that those two lines are parallel? Well, they're not distinct, meaning they're the same line, right? It's the same line on top of itself. So we wouldn't call a line parallel to itself. So that's where that word distinct comes from. It's just the idea that when we talk about parallel lines, we need the lines to not be the same line. Two different lines can be parallel, but the same line can't be parallel to itself. Make sense? So here's what two parallel lines look like for us. Two lines that do not intersect, like that. Now, what do you think two parallel lines have in common? And I'm going to label this red one, or the blue one, I'll call it L2, and I'll call the red one L1. Is that okay? What do you think the L stands for? Line, okay. I have line 1 and line 2, right? The red one, the blue one. What do they have in common? Think about the girl who makes 18 bucks an hour. Yeah, they have the same slope, don't they? I mean, if two lines are parallel, then that means the rise over run should be exactly the same. Shouldn't it? Would that make sense to you? So what we say is this: two parallel lines have the same slope. That's real important. Two parallel lines, plural, have same slope. So let's say that I gave you 2 points on that red line and said, hey, go find the slope. Okay, you could do it, right? If I gave you 2 points on that red line. And let's say you found it to be M1. We'll call it M1 because it's the slope of the first line. And then I said, hey, here's 2 points on that blue line, and then I asked you to compute the slope. You could find that, couldn't you? And let's say we call it M2. Then how would those two be related? How are M1 and M2 related? They're the same, aren't they? So we say they're equal. Whatever the slope of the first line is, it must be equal to the slope of the second line. If that's the case, then we can say they're parallel. Is that all right? So in the previous example, right, this one right here, what was the slope? What was the slope of the line going through those 2 points? 1/2, -2, 3/5, -5. What was the slope we found here? -30, right? Okay, the example we did before that, what was the slope of this line? -5/11. Are these two lines parallel? No, why not? They're not the same, right? -5/11 is not the same as -30. If they had both come out to be -30, then they'd be parallel lines. Okay? So in your homework, what's going to happen is that you're going to be given a line, and they're going to give you 2 points. And they're going to give you another line, and they're going to give you 2 points. And you say, are these lines parallel? It'll look like this. As an example, I'll try and pull it just the way it appears here. They do something like this. Example, are these parallel? L1, -1, 2, 1, 6, L2, 5, 7, 6. Whoa. Trying to make this work the way I want it to work here. Okay, are these parallel? So first, do you understand what they've given you here? L1 and then a colon and then 2 points. So they're giving you 2 points on the first line, right? And then the other one is L2. It's the second line. There's 2 points. How do you find the slope of L1? What's the slope of this first line? Y2 minus Y1 over X2 minus X1, right? Just like we did before. I'll call this one X1, Y1, X2, Y2. I want you to do the rest of this. I've got to go blow my nose. I want you to find M1 and M2. And then when I come back, you'll tell me if they're parallel. You should get 2 for the first one and -2 for the second one. Are they parallel? Yes? Is 2 equal to -2? No. 2 is equal to 2, right? 2 is not equal to -2. So these lines are not parallel. They would have to be exactly dead on the same number. They can't differ by a sign, because remember what we said. +2 means that the person's making money, right? $2 an hour. -2 means they're paying someone to work or something. You know, it's negative, it's going down. So these cannot be parallel if one's going up, one's going down. Okay. I don't like to go off on tangents, especially when we don't have time to go off on tangents, but I will, real quick. I want to just share something with you that maybe you'll appreciate. What we're saying right now is that when you have 2 parallel lines, they don't hit each other, right? They don't hit each other. That is true if you're talking about lines that live here. What is that again? That little R2, that's no, R with the 2, R with nothing is all real numbers. R with the 2, remember, was the flat plane, 2-dimensional space, the coordinate, the XY coordinate system, right? That's what we said. In 2-dimensional space, 2 parallel lines do not hit each other. Now, how many of you have taken an art class, drawing class? Nobody? Art, history, drawing, anything? Okay, just one? Okay, well, let me ask you this. Has anyone ever here seen like cave drawings, like old drawings of like thousands of years ago, right? They sucked at drawing, didn't they? I mean, I'm sorry to say it, but their drawings weren't very good, were they? I mean, they're like what you would expect out of a little kid, right? Little kid. They're, I mean, not quite stick figure. Well, kind of stick figures, right? They kind of were. Yeah, and they drew with rocks, and I mean, yeah, I mean, you got to give them some credit, right? I mean, I'm not taking it all the way, but even as time went on, it was difficult, you know, to draw. And the hardest problem is this: if I'm trying to draw, let's say, this classroom, right? I'm standing here, I'm trying to draw what I see. I'm trying to take something that lives in three-dimensional space, right? Like we're not on a flat sheet of paper, are we? Three-dimensional space. I'm trying to draw it onto something that's two-dimensional, flat piece of paper. And that's a challenge, and it was a challenge for a long time because what people were doing is they were trying to follow these rules when they drew, right? Trying to follow these rules. And if you try and follow these rules when you draw something, your drawing's going to suck. I mean, it's just going to be bad. What you need is a way of tricking the eyeball to think that something three-dimensional is on a two-dimensional piece of paper. You're trying to trick the eyeball, the eye, right? So here's the way it works. Watch. Let's say, I'll try and just draw this classroom real quick. Let's say I'm trying to draw this classroom, so I do this. Here's the class. Let's see, I've got a table here, table here, table here. I'm not even going to attempt to draw people, all right? Let's just say I have 6 tables in a room. And this is kind of looking from the top, isn't it? Like straight down on the room. Now, I want to point out the lines that are parallel. Do you agree that everything I've highlighted in yellow, all those are parallel, right? The edges of the desks are parallel lines. And then the other direction, these are parallel. And my drawing's not bad. I mean, it's not terrible. I'm kind of getting the point across. I've got a room, got 6 tables in it. But if I really want it to start to look like this room, right, then here's what I'll do. I'm going to create what's called a vanishing point. All right, there's a point. And I'm going to take all my yellow lines and point them towards that point. So watch. I'm going to draw the edge of the classroom over here, which is going to be this top, and I'll call it 1. That edge of the classroom, is going towards that point like that. All right? And then, let's say 2, this one is going to be over here, and it's going to go towards that point. Now, remember, I'm trying to trick your eye, right? So I need to draw some other lines. Now, let me just start putting this together, okay? I'm going to start drawing it, and I want you to see it start to come to life, all right? Here's the vertical walls in the classroom. And you know what? I'll take it all the way over. Like that. So that's that wall over there, and that's that wall over there. So I'm creating some sort of depth to this. Now, my table, don't try and draw this. It's gonna make your life hell. I don't like this drawing. Let me do something else. I'm not making the point. This one I think is too much to start with for illustrating what I'm trying to say. Let's do this instead. A road. Okay? Building, 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 building. You see all the parallel lines? Pretty much everything in that picture is parallel, isn't it? What I can do is I can make what's called a vanishing point, and all parallel lines will go to that point. So now here comes the road. Comes out like this. Now the center of the road comes out towards us like this. And then on the side I have a building like this. And then maybe on the other side I can draw another building like this. Now, that's a better road with buildings on the side, isn't it? But what I want you to notice is that in the picture on the left, all these yellow lines are parallel, and they should never hit each other, right? But to make your eye start to see it three-dimensionally, all those parallel lines are going to the same place, aren't they? Aren't they all headed towards that same point? That was a huge, huge leap for humans to be able to understand that to trick the eye, you had to break the classical rules of geometry, like parallel lines can't hit. Well, if you want to try and draw on what's called perspective, that's called perspective geometry, then you must break those laws, and there's a whole new set of laws. And if you do that, use those other sets of rules, then you can actually start to draw in three dimensionals, like 3 dimensions on a flat piece of paper. So I guess the whole idea of me telling you this is that when we talk about this rule here, just keep in mind that this rule only applies to a math class where you're talking about two-dimensional, R2. If you go take an art class, the first thing you're going to learn is that parallel lines will hit at a point that we call a vanishing point at infinity. So that whole rule of parallel lines, just throw it out the window. And there's all types of different types of geometry out there. Just depends on what you need to do. Okay, we need to try and finish up. Let's at least talk about perpendicular lines. And then I'll let you go. Perpendicular lines. So parallel lines in two-dimensional space, they go side to side, right? I mean, they basically keep the same slope the whole time, don't they? Perpendicular lines cross each other, don't they? But they don't just cross each other. It's not just like, it's not just like this. It's something else. They have to cross at a perfect T, all right? We call it a T, or we call it a 90-degree angle. So for perpendicular, you need one line to be doing whatever, and you need the other line to come in there, and we usually draw a little box, like just a part of a box, to let everyone know that that hits at a perfect T. That's the symbol for what we call a 90-degree angle, a right angle. Y'all seen that before? Maybe a long time ago? That's what two perpendicular lines look like. Now, do those two lines have the same slope? No. But their slopes are related to each other. But it's not what most people think. Most people think, okay, to be parallel, they have to be the same. So to be perpendicular, they have to be opposite. Like if one is 2, the other one's -2. That's not it. It's close, but it's not. So I'm going to tell you what it takes. Two lines are perpendicular. I'm just going to put perp. Or if you like, we use this symbol also. See that symbol right there? It's like an upside down T, capital T. Two lines are perpendicular if the slopes either multiply to be 1 or they are negative reciprocals. What the hell is a negative reciprocal? That's what it takes for two lines to be perpendicular. Either you take the two slopes, the slope of each line, you multiply them and you get 1. Right? Did I put 1? Hold on. Not 1. -1. I forgot -1. -1. Or they are negative reciprocals. So let me give you some examples of what slopes of two perpendicular lines would look like. So here's an example. I'm going to say, what if M1 was equal to 3 and the slope of the other line, M2, was equal to 1/3? Would those be parallel? Parallel. Parallel? Bueller? Well, but I'm saying parallel though, not perpendicular yet. Are they parallel? Are they the same slope? I mean, is it the same? Is 3 1/3? No. So they're not parallel, right? Are they perpendicular? Well, let's just check it real quick. What's 3 times 1/3? That's 1, isn't it? What does it have to be? I messed up earlier. I said 1, but I corrected myself. It has to be -1 if we multiply them together. Is it -1? No. They are not perpendicular. And they're not parallel, right? If they're not parallel and they're not perpendicular, then we say they're neither parallel nor perpendicular. So you can have two lines not be parallel and not be perpendicular. That's perfectly fine. Let me try this one. M1 is 3. M2 is -1/3. Now are they perpendicular? Yes. 3 times -1/3 is -1. That checks. They are perpendicular. And you could tell right away they weren't parallel, right? Because they weren't the same number. You tell me, what would M2 have to be here if I wanted these to be parallel? What would it have to be if I wanted them to be parallel? 2/7. What if I wanted them to be perpendicular? -7/2. Now that's what I was talking about when I said negative reciprocal. If you look at 2/7 and you flip it, that's reciprocal, and you change its sign, make it negative, then they'll be perpendicular. Because what would happen if I multiply those together straight across? I get -14/14. -14/14 is -1. One more, and then I'll let you head out. I'll have to give you your homework still. What if I gave you -3/4, and I wanted something to be perpendicular to this? What would it have to be? +4/3. So you're just taking the opposite of what's there and flipping it over. That would make it that would make them perpendicular. Okay, for your homework, try and squeeze this in the side here. We're going to go off page 228. I want you to do 33 through 45. I had promised you all a quiz today, didn't I? Do you remember that? No? 51, I'm not going to do it, but through 56. Okay, the first one was odd, sorry. This one is all. And then 57 through 67, odd. That's a lot of work. It's a lot of homework right there. Y'all understand? 33 through 45, just do the odds. 51 through 56, do all of them. 57 through 67, do odd. 228. Everyone have a good day. Anyone else need to sign in?